Welcome to our physics class for today. Today's class will be dealing on the movement of a force. The movement of a force about a point is defined as the product of the perpendicular distance from the point to the line of action of the force and the force. The movement of a force is also known as the turning effect of a force. We have to note certain things in this definition. Number one, movement is always defined about a point and is the product of what? The perpendicular distance from the line of action of the force, the line of action of the force, and the force itself. So that is the definition of the movement of a force. Now, movement of a force is what? The force under consideration times the perpendicular distance from the line of action of the force. One of the things that I've seen as a problem to many students is that they find it difficult to be able to identify the line of action of a force. Now let's consider this diagram. Now the force under consideration is 20 Newton. Now the direction of this force is what we call the line of action of the force. The direction of the force is what we call the line of action of the force. So when we are taking our moment, we will be looking at what? The line of action of that force. Now, let's say we are taking moment about the point O. Let's take moment about this point. That is the point where the turning effect is. Now, what is the force causing the object to turn at this point? Obviously, the force is what? Is 20 Newton. Now, movement about O will be what? The force. The movement will be the force, which is what? 20 times the perpendicular distance from that point to the line of action of the force. Now, this is point O. The only distance, if you go through this point O, the only perpendicular distance from point O to the force is just this distance, which is this is the only point that is perpendicular to the force when we move from O to that force. So times what? 0.4, and that will be 8 Newton meter. That is, moment is measured in Newton what? Meter, because it is force times distance. Now let's again take moment at another point. If we take moment at another point this time, let's take our moment at point N. Now again, the moment will be the force under consideration, which is 20 times. Now let's look at the perpendicular distance. What is the distance? You know that this is the distance from N to what? To the force. This distance is perpendicular, and the distance is still again 0.4, which is 8 Newton meter. Now, let's look at more example. Let's again, how do we define moment in this system? Let's assume that the body, this is our knife edge where the rotation or the turning effect is. Now, the first thing we know, this is the force producing moment. So, moment will be force F times perpendicular distance. Now, this is the line of action of the force. You can see this is the line of action of the force. Now, we need a distance that is perpendicular from the point, the knife edge where it's turning, to the line of action of the force. If we move like this is not perpendicular to the force, but if we move like this is what? Perpendicular to the force. So what do we have to do? We have to find this distance. Now, you can see that this is a triangle and this distance. Now, the triangle is a right angle what? Triangle. Because it's a right angle triangle, we can what? Find each of the side. Now, this is the opposite. That will be what? D sine theta. Whereas this place will be what? D cos theta. Now, because D cos theta lies on the line of action of the force, it will not produce moment. If it lies at the line of action of the force or on the plane, it will not produce what? Moment. So the perpendicular distance under this case is what? Is D sine theta. So what's our definition for moment now? That will be F D sine theta. Now let's look at another case. Now again, we are having this force. We still have our knife edge here, the turning point. Now the first thing to do is we can resolve this force because the force is inclined at an angle. So we don't have any perpendicular distance to that force. Unlike the one we just took, look at this. We have, if we move like this, it's not perpendicular to the force, but if we move like this, it's perpendicular to the what? To the force. So in this other example, there is no distance that is perpendicular to the force. Since the force is inclined at an angle, the first thing to do is to what? Is to resolve that force. So opposite is always sine. That will be F sine theta. Adjacent is cos. That will be F cos theta. Now we can redraw that diagram. We are going to have this is F sine theta. Now the one that lies on the plane is F cos theta. Now this is our knife edge, and this is the distance. Now this distance is perpendicular to the turning point. So what's our moment now? Moment will be the force, which is now F sine theta times D. The distance, the perpendicular distance. And so that will be F D sine theta. Now that is the moment there. Now let's take one more example. Question of moment. Now the force is perpendicular to the distance. So if we take moment about this point, we will just have our moment to be equals to F, which is the force, times the perpendicular distance. That will be FD. So I want you to settle down and master how to determine the perpendicular distance to the line of action of the force. Our next class will depend heavily on this. Thank you.